Before going to a specific topics for today we are planning to talk about Einstein's relativity theory, special theory of relativity. Before going into that, why not you introduce yourself, especially your upbringing and what triggered you to investigate in that direction?
Yeah, I was brought up in a Catholic family. My father was a doctor, medical doctor,
Mhm.
in a small town in southern Jersey, New Jersey. And they were more nominal Catholic.
Mhm.
But when I was in college, I had, in my freshman year, I had a very intense spiritual experience. And it was just as if Jesus was in my room talking to me. Not that he was, but it was just as if it was. It was so powerful. And I had been reading the Bible for quite a while, about 6 months. And one night I went to sleep with a particular verse on my mind and woke up the next morning, and I was not the same person as I was the night before when I went to sleep. I knew something had changed drastically in me, in my inner man. And
What was the verse?
the what?
What was the verse you just read
Oh,
before?
the verse was Matthew 11:25-28,
Mhm.
which Jesus says, "Come unto me, all ye that labor and are heavy laden, and I will give you rest. Take my yoke upon you, and my burden is light." And yeah, it was like he was talking personally to me. It's one of the most unique passages in the New Testament because that's the first time Jesus actually says something like that, you know. Um, and it's very personal. So that's the verse. And it changed my life. I was 19 years old. And up until that time, I can honestly say I didn't really know who God was. Even though I was brought up Catholic, I didn't understand too much of it. I knew all the rituals and things, but I didn't know what they meant and why they were here and why we were doing them and all that. So um, I since I had that experience by reading the Bible, I figured, wow, this book is powerful, and there must be a lot more in here. So I dedicated my life to studying the Bible, and I did that for the next 10 years. I used to get jobs at hotels on the graveyard shift, just so because they had no business in the graveyard shift, basically, and just so I could study the Bible. And I did that for 10 years. And so that's how I got into my Catholic apologetics. And I've written probably 30 of my 50 books on apologetics, Catholic apologetics, Bible study,
Mhm.
theology, things of that nature. And then, and I went to Protestantism for about 17 years because the Catholics, as far as I was concerned, weren't following the Bible, and the Protestants were, and so that's where I wanted to be.
Mhm.
And so I switched faiths to the Protestant world, and um, then in 1992, I was challenged with the fact that the Catholics were using the Bible. They just weren't using it the same way the Protestants were, and that the original interpretations came from Catholics back in the first centuries.
Mhm.
And we still have those interpretations today. So I figured, oh, well, maybe I ought to look at that. And so I did, and I was convinced, yeah, the Catholics have a better hold and understanding of the Bible than the Protestants do. And so I became a Catholic.
Mhm.
And that was, 27 years ago or so.
Mhm.
And 1 year after that, I was searching on the internet. I was a Sunday afternoon. I had nothing to do. I was searching on the internet, and I came across this PhD in astronomy who was saying that the Earth was in the center of the universe and the universe went around the Earth. not the earth moving around the sun. And I had to make a decision because I thought it was wacky, but I had to say, I give everybody a fair shot. So I had to make a decision whether I was going to push the next button to get into his website or I was going to go outside and play basketball. And I decided to stay and push the next button. And then I got into his website and I began reading it. And since I took physics in college, I was a physics major for a while. Then I had dropped it for theology. But I knew enough physics to discern whether this guy knew what he was talking about or he was just a sensationalist, And I was pretty well convinced by about a couple hours of reading that there was something to this idea that the earth was the center of the universe and didn't move. And so for the next, let me see, that was 2003. By 2006, I had published a book on it, which is Galileo Was Wrong. So basically I had done 3 years of study, intensive study on this issue. And it was important to me because as a Catholic, the church had condemned Galileo for believing in heliocentrism or Copernicanism. And not only condemned Galileo, but condemned Copernicanism as a heresy, a formal heresy back in the 1600s. And it made sense to me because I said to myself, well, if God's leading the church and said he promised to lead it into all truth, not some truth, and if the church thought this was important enough to confront Galileo, well, this has to be part of the faith that he wanted us to know. And therefore, the church decided to condemn Galileo. So to me, it made sense because if the church is true, it has to be true on everything, not just some things. If there's one thing that it's not true on, then the whole thing's false. I knew that instinctively. So this Galileo thing had always been bothering me, and now it made a lot of sense because, okay, God's leading the church into all truth, including this issue about cosmology. Because the Bible claims that the earth doesn't move, okay? And the church interpreted that literally and thought enough of it to condemn the opposite view as heresy. So I said, okay, now everything makes sense to me. So that's why it was important. I wanted to vindicate the church. And this was the last peg that needed to be pulled to vindicate the church. Because for the last 400 years, the church has been criticized and ridiculed for condemning Galileo. And I figured, well, what if it's true? What if it's true that they were right in condemning Galileo?
As of now, church never reverted or accepted whatever Galileo said might be true. They always kept their position, right? Officially.
Officially, yes. Unofficially, there's a lot of people who are pro-Galilean in the Catholic Church today, and they're more liberal people. There's a lot of conservatives, however, that still believe Galileo was right. But that's because they haven't been educated. I'm one of the first Catholics to come along and show them from the science that the church was right.
Okay.
And so it's going to take a while for them to have that seep into their consciousness.
For the outsider who are primarily scientifically thinking and they're brought up is like religious. That means they kept religious belief totally separate and their education is totally separate. So, for example, for me, so when we grew up from the very beginning, since childhood, that paradigm is so much ingrained in the system that the moment you say something like that earth might be center and the earth might not be moving, relativity theory might be wrong, automatically people think either you are from different world or you are not scientifically educated enough or you are just religiously fanatic or literalist. That means whatever Bible says, you take it literally. That means it has to be true. But after seeing your work and also thinking by myself, and when I also studied a little bit, I come to realize actually it's by convention. Like even the scientists who propose that heliocentric model or relativity, etc., frame of reference, they always, even in their own work, they say is by convention that
Yes.
we have to accept that Earth is not centered because you cannot prove or disprove, but we already know that Earth is moving, so that's how they build up their theory. But when we grew up, we thought that's a empirical, observable, scientific fact. It's not nothing to go with belief, right? But at the end, as of now, based on my literature studying and based on your work, I can see still a convention. So can you elaborate on that? That how scientists themselves see this particular situation, the principle. I'm talking about Copernican principle.
Yeah. Well, the first thing we have to know is philosophically, what does it mean if the earth is in the center and isn't moving? Philosophically, theologically, culturally, what does that end up meaning? It means God exists. Because every scientist out there knows that to have the earth in the center is not going to come by chance. Okay. That means there's something special about us that is not special about any other part of the universe, whether you believe in aliens or not. And most scientists are atheists, and I document that in my book. The National Science Foundation did a study and found out that of the premier scientists in the world, the ones that are in the movies, write the books and all that stuff, 90% of them are atheists. Okay. So if somebody comes along and says to them, well, you know what? We've been wrong about this whole thing about the earth. It actually is in the center of the universe. The first thing that happens in their mind is, uh-oh, my whole world is now going to be turned upside down. And that means there's a God, because they know it's not going to happen by chance. And I'm not making this up. I've read it in their books. Okay. They all say the same thing. So whether they can prove it or not, they're going to side with the Copernican view, be just philosophically speaking. Carl Sagan was famous for this, saying that the earth is out there in the remote recesses of space.
Blue dot.
Yeah, the big blue dot, all out there all by itself. You know, and how it got here, it's all time it chance. It just happened to be that the chance factor was lessened to such a degree where we produced human beings on a planet that was conducive to their life and their growth. And so he'll accept that chance. But if you told him that earth was in the center, he knows that somebody put it there. And that means he's responsible to that being, because that being is greater than him. And he writes about that in his books. He has all kinds of derisive comments about God. You know, we think God's this, you know, old man up there with a big beard and all this stuff. And he's all constantly doing that in his book. So you can tell where he's coming from. He's a total atheist. And so that's the block, philosophical and psychological blockage I run into all the time, you see, because smart people know the implications of what I'm saying. It's not just a matter of what goes around what. So they will side with convention. As a matter of fact, most of them will say, but Copernicus taught us that the earth goes around the sun. But you know what? None of them have ever read Copernicus. And they don't know the history of how Copernicus got to where he is. And they don't know the history of the Greeks. They don't know. They know nothing. They all have assumed certain things. And because of that, and because of the psychological, philosophical basis from which they start, it's hard to move them to the other side. Now, I will get some people that, look, they know what the world is. It's a bunch of lies. Today you can't even tell the truth from a lie sometimes because things are so confusing. And so they know how the world runs. So their mind is open to the fact that, well, maybe possibly we've been deceived all this time and we haven't really looked at the evidence, the scientific evidence. And so they're more open. And I've had some people convert to the geocentric side because of that. And one of the main things is because of what Albert Einstein did. And you wanted to talk about Albert Einstein today. Exactly. Well, that's a lot. That's where the whole thing pivots upon Albert Einstein, because he saw the implications and he invented his theories to try to deal with those implications. Okay, so he's a good place to start.
Our discussion will be mostly today's on Einstein's special theory of relativity, not even general, because that's a different kind of situation there. But before going there, I just wanted to ask you a few simple questions that based on your theory or your understanding of the literature, of existing scientific literature, it's not your own theory, based on the data that science can provide us, you're saying Earth is not spinning, that's number one, and Earth is not moving around the sun also. So not only spinning, there's no movement at all.
Right.
So if that remains the situation, remains the fact, then the natural next question comes that the moon, then the sun and the star, those are physical objects, right?
Yes.
If those are physical objects, then what gives them the power to move? Because for any movement, you need an external force in general,
right,
or some mechanism. Because if it is, for example, if it is something just light, then light or fire is not a physical thing. They don't have any weight. They can move easily. So it's easy to explain if it is just a like luminous phenomenon. But if you are talking about physical large body, then in order, that question actually I have no clue why that thing happens. So what's your understanding that what mechanism allows them to move around the earth? What is pushing them?
Yeah, it's a good question, and that's basically where someone should start. If you think of the universe not as the Big Bang Theory does, which is an open-ended expanding entity, but you think of it as a closed sphere, then you have an entity that can be analogous to a bowling ball, let's say, that you spin. Okay, you know what a bowling ball is. It has a surface and it has all this stuff inside of it that's solid. Okay, and you can turn it, and that's the better picture of the universe as a solid sphere. Okay, now someone might say, but there's outer space out there. It's space. It's not solid. Well, we've come a long way since then. Quantum mechanics will tell us it's not empty space. Einstein used to say that in his special relativity, that the ether didn't exist and therefore it's just nothing. Well, philosophically speaking, you can't have nothing. Nothing means it doesn't exist. Okay, so there has to be something between the earth and the moon, something between the earth and the sun. And that something has to pervade all the universe. And what quantum mechanics has told us is this substance, whatever it is, comes in the smallest, most discrete dimensions that we could possibly think of. And it's called the Planck dimensions, after Maxwell Planck, or Planck actually is the way you say it. And so we can't see it, We can't feel it, but it's there. It's just like air in a room. You can't see it. You can't, well, you could feel it if you moved your hand, but you can't see it, but you move through it. Okay. But these things, the Planck dimensions, are much more discrete, much smaller than the air molecules that you're used to either breathing or sitting in or whatever, what we're doing now. So there's, in other words, there's substance to the universe. And if that's the case, then if this universe is rotating daily with that substance, it's carrying everything with it. In other words, it's carrying the stars, it's carrying the sun, it's carrying the moon, blah, 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 all as one unit. So it's not the individual star that's moving. It's the universe behind it that's turning it, you see. That's why we see the stars go around us every time. Now, this is a good model because a big mass like the universe has a lot of inertia. And that inertia, once you get that thing spinning, it's going to spin at that same rate, which we call the sidereal rate, 23 hours, 56 minutes, 4.1 seconds, every single day, because since the universe has so much inertia, there's nothing that can stop it. That's why we have the same period every single day. It hasn't changed. It might change a microsecond here or there, one day to the next, but it's always averages in that 23 hour, 56 minute, 4.1 second. So that's good, as opposed to the Earth spinning in a universe, but that Earth is bombarded by internal and external forces that should cause it to slow down, and quite drastically. Earthquakes, tsunamis, volcanoes, planetary perturbations, cosmic dust from the sun, meteor showers, all kinds of things are bombarding the Earth externally and internally to make it slow down, but somehow it doesn't slow down. How is that possible? Because when we examine the other planets, like Venus, that planet has slowed down its rotation 6 minutes in 10 years. Saturn's doing the same thing. It's slowing down. Okay. So what's different about the Earth? Why does this Earth have such a stable rotation? Well, you can't explain it by the Copernican method, but you can explain it if the Earth is still and the universe with all its inertia is turning around it every day.
Yeah, that model is totally different than the proposed Big Bang model, obviously.
Yeah, very, very different. Yeah.
It requires ether, and ether in itself is an interesting concept. I personally agree with you that nothing cannot exist, because whatever exists, there is a thing underlying. So I think now the scientists use a different word, but they express very similar idea to ether, like quantum vacuum fluctuation, 0 point energy.
Yeah.
Then Higgs field.
Higgs
These
field,
are all the very similar phenomena to ether, but they don't use the word ether, because the moment you say ether, you have to accept whoever rejected Einstein. So you are rejecting indirectly Einstein. So they don't use the word ether.
Right. But see, now here's an interesting thing, though. And this is where we have to jump to general relativity just for a few minutes, because in general relativity, Einstein took back the ether that he had rejected in special relativity. Okay. And you're not taught that in college or when you're getting your PhD in physics. Now, or they may be taught it, and it may be like a secret they keep, but they don't let it out into the public that he took back the ether. As a matter of fact, he said, if you don't have ether, then you don't have a medium for light.
Exactly.
But in special relativity, he said you don't need the ether because the light makes its own medium.
It doesn't make sense, to be honest.
Yeah.
And as you know, even the EPR paradox, the paradox that non-local variable, Einstein was saying there cannot be a non-local variable because there is no ether. But at the end, it is found that there is actually a non-local variable that explains the instantaneous communication. How can it can be possible unless the ether exists?
Yeah,
But they
as a
don't
matter
they
of
don't
fact,
say the word ether in that context.
no,
They will
it
do
won't.
all kinds of mathematical
Yeah,
expression, but the fact is everything is always connected by underlying medium, and that is traditionally called ether, and that explains the EPR paradox
yeah,
or
that's right.
Bell's theorem, right? But anyway, it's interesting that scientists still use the identical concept of ether without using the word ether.
Yeah, well, that's why Einstein and quantum mechanics had such a fight, because quantum mechanics says, look, it's either you call it a rose by any other name is still a rose, as Shakespeare said, you see. But he just never got there until the end, until actually what? It was 10 or 15 years later, he actually came to the quantum mechanics side and admitted that the ether does exist. But you know what's interesting is if you have this ether in the Planck dimensions,
Mhm.
all the mysteries that we have had prior are solved, because in a Planck dimension universe, these particles are so small and so compacted together that gravity can go from one side of the universe to the other in 10 to the minus 11 seconds, if you do the math. Okay, now that's always been a problem in conventional Copernican cosmology, because they had no medium for the gravity to travel through, you see. But if you got a compact Planck medium, gravity solved. Now we know how it can travel. Now we know how the double slit experiment can work, because one electron can communicate with the other millions of miles away, because there's a medium for them to communicate, so to speak, you see. So a lot of problems are solved when you bring the ether back, and modern science is beginning to discover that. They already discovered it back in the 1920s, and now it's just been one step after the other. There's a guy that I quote in my book, Dr. Robert Laughlin, PhD physics, who won a Nobel Prize. And he wrote in 1993 in his book, he said, it's strange to see that Einstein's first theory, special relativity, was totally put upside down in his general relativity when he admitted that there was an ether. And he says, now I can say that because I have a PhD and I won the Nobel Prize. But if I was some low-level scientist who just discovered that about Einstein, I'd lose my job if I had said that, you see.
He got the prize already. So now whatever he says, nobody will
Yeah,
achievement he already got.
yeah,
Yeah, that's another one, like indirect way of censoring the information that is really true. It happens all the time. It's not necessarily with the evil intention. It's just to, sometimes I feel this mechanism exists to preserve the power structure.
yes,
Whoever is in power, they actually want to keep the power, and they are staying in the power using all this mechanism or
yes,
machinery. So
yeah,
if one of them goes, actually they don't care. For example, if the relativity goes away, but their power structure remains in good shape, they will forsake relativity in a second.
yeah. See, that's when the dam breaks. Until then, there's pressure on the dam to
Mhm.
keep that water back, and then the dam breaks, and then everybody scrambles to try to save whatever they can, you see. That's just the way human nature works, and that's the way science has worked for the last, what, 500 years. They will only change when they're forced to change, and when they're forced to change, then everybody gets on the lifeboats and goes their way. But it takes a lot of pressure to make that change.
I think the situation is changing. Hopefully, in next 20, 30, 50 years, the new theory will come. At least you'll re-acknowledge the existence of a medium for the light to travel.
Yeah,
Either they will call it ether or not, but they will re-examine that. Right now, for the light, the official statement is it doesn't need any medium.
yeah,
But probably they will reformulate and they will give a brand new name that medium is needed, something like that.
yes,
That's one change. And the second change, I think the theory of gravity probably will change. Although all physicists are very fond of general theory of relativity because it's more like mathematical mysticism. It's like
yeah,
goes
exactly.
deep
Yeah,
inside, exactly. but eventually it will fall because I think the prediction doesn't match. Plus, a lot of phenomenon is not necessarily gravity can explain. So things will change.
A cesium clock,
Mhm.
if it's placed at a very high altitude, will tick faster than one at a lower altitude that's on the ground
Without any movement.
without any movement. Okay. So the question is, why is that the case? Well, relativity has their answer because they've relativized the whole atmosphere to
Mhm.
try to explain this. We can explain it naturally in the sense that the cesium clock that's on the ground has more gravitational potential against it than the cesium clock at 50 miles above the Earth.
Mhm.
It's a natural understanding that the gravity potential is going to affect the tick of a cesium clock. So the clock will run slower on Earth than it does at a high altitude. They've shown that. But it's not relativistic, is what I'm trying to say. You don't have to have general relativity to explain that. You just explain it by natural phenomena. That is the gravity force on it. It's also the fact that the GPS satellites that we use, this is an interesting story. This is fascinating. The GPS satellites, if you have one in the east and
Mhm.
it's sending a signal to a GPS satellite in the west,
Mhm.
okay, that signal will travel faster than if you have that signal go from the west to the east. And it does so every day, all day, every time they do it. And it's a
But it's
difference.
supposed to be equal, right?
They're supposed to be equal
Based on Einstein's theory.
based on special relativity.
Yeah.
Speed of c is constant, according to Einstein. Ron Hatch is his name. He's dead now. He died a couple years ago.
Okay.
He was in our movie, The Principal.
Okay.
He was interviewed in The Principal. Ron Hatch used to work for John Deere. Well, he used to work for Navcom in California,
Mhm.
and Navcom contracted with John Deere Tractor, and Ron Hatch, Hatch,
Mhm.
was assigned to make the tractors of John Deere go down the fields without a man driving it. And so
Okay.
they had to use the GPS satellites, okay, in order to do that. And Ron Hatch has stuff all over I hope it's still up there because he died, and I hope his wife or somebody kept it up there. If not, I have in my book, Galileo was wrong. So at any rate, in order to make these tractors go straight down the field and not right or left,
Mhm.
you have to program them with the GPS precisely, okay? So Ron went into the GPS program and he found that what they did was they pre-programmed the computer of the GPS satellite
Mhm.
in order to assume that light speed was constant.
Okay. Okay.
So, in other words, they fudged it because they knew that the light speed was not constant, because when they sent the light beam from east to west, it was faster than west to east every time. Okay. And if you're wrong by 50 nanoseconds, that means you're going to be off by 15 miles. So all those little GPSs we have in our cars,
Mhm.
okay, you'd get to your direction 15 miles away from where you wanted to be.
Wow.
Okay.
Wow. Wow.
So now,
Unfortunately, using GPS, all the scientists are trying to say because GPS works, relativity has to be proved. So that's the proof.
yeah,
Relativity has to be true.
has to be true. So they start with Einstein has to be right. And so what do? You go in there and you pre-program the computer to make Einstein right. But you know he's not right because you see the evidence in front of you. But they don't tell you that on TV, you see? Nobody knew this except Ron Hatch. And how many years did it take him to go in there and find it? Well, he was only prompted to do so when he had a contract with John Deere to make the tractors go straight. Otherwise, he wouldn't have known himself. And he works for Navcom.
Since 1905, as of today, a lot of independent researchers still working to show that whatever Einstein is saying doesn't make any sense philosophically and doesn't match with the experimental data. It automatically proves actually any open-minded people who are looking for truth should investigate to find it by themselves that something is wrong with this theory. They are hiding something. They are not telling you the full truth.
Yeah. And, Einstein became an icon of human society in 1919, 1920, because he supposedly found the reason he found that light bent. That was his prediction. And so Eddington did these eclipse experiments, and he only found one instance where Einstein had the correct measurement for a star. All the other stars, there are about 25 of them, he got them all wrong. But you don't hear about that. But he became famous for the one star that he predicted that was going to bend the light, in a certain direction. And so he became an icon. And basically, you had to agree with Einstein on any physics topic for the next, up until today, till 2020. You will lose your job if you go against Einstein. They will not publish your papers. And Ron Hatch knows all about this too. So he used to tell me about this. And once you get an icon there, it's good luck, trying to get a new idea in there.
Mm-hmm. Mm-hmm.
Now, I want to just spend a few little minutes on the special relativity, because you need to know why Einstein invented special relativity in order to understand what the motivation was. In 1887, Michelson and Morley did an experiment, and they crisscrossed light beams. And their theory was that if the Earth was moving around the sun at 30 kilometers per second, then one of those light beams should be impeded. And they could tell you exactly the length it would be impeded by their knowledge of wavelengths and everything. They knew all about that. Everything was all calculated out. And when they did the experiment, they found that the light beam that should have been impeded
Mm-hmm.
in the direction of the Earth's movement around the sun wasn't impeded. That virtually both light beams were going the same speed,
Mm-hmm.
whether one was directed to the direction of the Earth going around the sun or directed up and down. It didn't make any difference. So they were flabbergasted at this.
Mm-hmm. Mm-hmm.
The others, and they're trying to find out if they can prove that the Earth moves. And this experiment showed them they can't prove it because the light beams are going the same speed. So what's the opposing interpretation of that experiment? The opposing interpretation is that the Earth isn't moving. And that's why the light beam wasn't impeded. That's why both light beams go the same speed.
Mm-hmm.
Now, of course, you can't have that in modern science. Okay? Look, you're following Newton and Maxwell and Paulus and all these guys, and they all believe in Copernicanism, and you're telling us now that you can't even prove it? Well, we can't have that. So what we'll do is we'll assume the Earth is moving, and then we'll try to give an explanation for why these light beams were going the same speed. And so Lorentz comes along in 1892, and he says, well, the only way that could happen for those light beams to go the same speed is that one of the arms of Michelson's experiment had to shorten in its length, and therefore the light didn't have to travel as far, and it made the light beams look like they were going the same speed because the arm of the interferometer shortened. And everybody's like scratching, are you telling me this is the best proof, the best answer you can get? Because look, we have no other answer. It's the only way it could work. And so he devised this phenomenon called the Lorentz transform, where the length of the arm is changed because it's moving in space. And he attributed it to ether. He said, when the arm's moving against the ether's making it shortened, you know. And so that's all they had.
At least he was polite and not to shorten the time. At least he was talking about the physical object. Einstein did even the worse.
Yeah, exactly. And so, you know, Einstein, you seem to know the story. Einstein didn't like the ether doing the job because that would make things absolute, and he couldn't have absolutes in his relativity theory. Mm-hmm. Everything had to be relative. The only absolute he had was the speed of light. So that's what he chose. He had two choices. He could choose the Earth as not moving, or he could choose light speed as being constant. One of those has to be true. So, and of course, he's not going to choose the Earth not moving, not being the child of science that he is and the atheist that he is, because he knows if the Earth isn't moving, then it's in the center of the universe, you see. So he's going to choose the other option. That is, let's make light speed the absolute. Let's make that constant instead of making the Earth constant. There you have it. But when you do that, then what has to happen? Well, as you said, if you're going to say that light speed is constant, then the length has to change. So he has to agree with Lorentz that, yes, the length of the interferometer did change. He doesn't know exactly how that happened, but it did. And what else has to happen? Well, you have to change the time. Because if the light beam's traveling from A to B and you make B shorter to A than you did before, well, the light speed is traveling at a different time. You see, it has to dilate the time. What else do you have to do? Well, you have to increase the mass. Because if you have the mass now going from A to B, you have an increase in mass now because you've changed the length. You see? So there you go.
So everything is changing. Mass is changing, length is contracting or getting bigger, and time is also getting shorter or longer, just to keep the interpretation safe and sound. The Michelson-Morley was such a big experiment, right?
Oh yeah, probably the greatest experiment in physics in the whole history of physics.
Yeah. You read the literature quite extensively. I'll ask you a few simple questions based on your literature review. What's the consensus? For example, speed of the light despite moving the source remains the same, or actually it changes depending on the source of the light. What's your...
Oh, well, they're correct there. But that has nothing to do with the Michelson-Morley experiment. You see, it's just like a sound wave. The sound wave can only go so fast, depending on the medium, of course, and you're going to get the effects of that. So light beam in our terrestrial environment, it's going to go 186,000 miles per second. Okay, that's understood. The question is, if the light beam is moving in a non-inertial frame, not an inertial frame. Okay, an inertial frame is one without gravity, inertial forces, or ether. Okay, yeah, if that's true, it's going to go 186,000 miles a second. We all understand that. And so even if the source moves, light can only move 186,000 miles a second. That's understandable. Okay, but when you have a non-inertial frame, that's a frame with gravity, inertial forces like centrifugal force, Coriolis force, and Euler force, and you have ether, well, now you have something that's acting against that light. So it can't go 186,000 miles per second every time. Something is impeding it. What's impeding it when the GPS satellite sends the electromagnetic beam from east to west as opposed to west to east? It's the ether, you see, because if the universe is rotating east to west, then a light beam going west to east is going to be impeded by the ether in the universe. You see?
Okay.
And the same for the other side. If the light beam is going with the ether as the universe is rotating, then it's going to be faster. You see? So we have explanations.
That means depending on the frame of references and the medium, if the medium itself for example, in empty space, based on your understanding, is filled with ether, and the ether itself moves, it
It's
also adds or
that's
subtracts
right. That's the
to speed
key.
of light. This simple fact, nowhere you can find in literature. I try to find,
No,
they give you all kinds of equation and difficult to understand experiment using particles that you cannot see, like muons or some particle collider. But they don't give you macroscopic experiment. Like, for example, if I have a synchronized atomic clock with you and you are 10 miles away from me, and if I turn on my laser that is synchronized with my atomic clock, and you have a receiver, and that receiver will automatically freeze the atomic clock that was synchronized to begin with. That will give a concrete speed, right? Now I move towards you and let's do the experiment again and let's compare head to head. But this kind of simple macroscopic experiment I cannot find anywhere.
no, you won't find it. You
Why
won't
is
find it
that?
because they're in a paradigm.
Okay.
They're in a paradigm. And the only thing that's going to get them out of that paradigm is
Yeah.
if some cataclysmic thing
It
happens.
might generate a data that will contradict Einstein and it's not allowed.
No, you will lose your job. If you are a professor, you will lose your job. Now, there have been people I know that I write about in my book that have challenged it. And they will say, honestly, the other answer to Michelson Morley is that the earth doesn't move. There were many people I quoted who said that.
Mhm,
But they could say that at that time because Einstein wasn't exactly famous, you
Oh.
see. After he became famous, then everything was locked up. And his only battle that he had after that was with quantum mechanics.
mhm,
And that's it. But who knows all about that stuff? That's, esoteric stuff. And he did try to find his unified field theory and failed there. And then after, toward the end of his life, Einstein became a lot less respected with scientists because they knew there were flaws all over the place, and that he was trying to come up with a new theory every other year to try to patch up the flaws in his original theories. And it became a joke after a while. I know some scientists, famous scientists, who actually joked about Einstein. Oh, here's another theory of Einstein, At any rate, now what's interesting with the general theory is that everything he said in the special theory changed. He took back the ether, and he said that in a general relativistic framework, you have a non-inertial frame. That means, guess what? Light is not constant. He said that. Einstein said that. Light's not constant in a non-inertial frame, but it is constant in an inertial frame. So the question is, okay, where in the universe are you going to find an inertial frame? One without gravity, inertial forces, or ether. Where are you going to find that?
No,
Nowhere. So his theory was idealistic. It only worked in theory, not in the real world. The real world came when Einstein invented general relativity, and he says, okay, we got to take all these things into account before we start saying that light speed is constant.
So far, actually, regarding the special theory of relativity and speed of light, I can summarize quickly because we are talking a lot of things. The key experiment was Michelson-Morley that apparently did not show changing light speed because they already assume Earth is moving, so the speed should add up. But speed was not adding up. So the conclusion should be either Earth is fixed or length or time for light is changing. So somehow the scientific community accepted the unlikely, unpalatable, counterproductive, and logically contradictory conclusion rather than accepting Earth is still.
Yeah.
Okay, that's part one. And part two, GPS data that you describe, your friend and the person Ron Hatch, actually shows the speed adds up depending on which direction. That means speed changes depending on which direction the light was being thrown, or electromagnetic or radio or whatever radiation you're talking about.
No,
So this
Ron believed
data
in you.
actually very goes against Einstein. Is there any other very good experiment that I can read personally or refer to my friend in your mind that actually goes against Einstein's special
Oh,
theory?
yeah. Yeah, I write about this all the time in my books. It's the next experiment that Michelson did with Henry Gale in
Gale,
19, yeah,
Gale, right?
Gale, right. And
Mhm.
Pearson, Pearson. Three guys. Michelson's an old man now, but he's still searching for his ether. He never accepted special relativity because even in his 1887 experiment, he
Mhm.
got a little positive result. It wasn't that the light beams were exactly the same speed. One of those light beams actually did go faster than the other, but a minuscule amount. It was certainly not enough to account for an Earth going 30 kilometers per second around the sun, but there was a little amount. So he's still on a hunt for this ether. He wants to devise an experiment that will show the full ether effect,
Mhm.
all the ether. He wants to see it. So he devises an experiment in 1925 that instead of pointing one of the light beams in the direction that the Earth is supposedly going around the sun, what he did was he made the light beams go in the direction of the rotation of the Earth. Okay. Now he believes the Earth is rotating. Okay. So he sets up this rectangular um, tubing that the light can go through, and one side is going this way, so that would going east to west, and then it comes down here and it goes this way, and so it's going west to east. So he's got two different directions for the light. Okay. Now it gets all complicated because I can't go into too much of how he devised it, but the essence is that he's using light to measure whether there is a resistance from the ether. Same principle that he did in 1887.
Mhm.
Okay.
Mhm.
All right. So what does he find? He finds that there is that what happens is the light speed is slowed down to the exact amount to account for a daily rotation between Earth and space. In other words, he comes up with a sidereal rotation rate, 23 hours, 56 minutes, 4.1 seconds, because one of those light beams was impeded enough to coincide exactly with that daily rotation rate. And then that daily rotation, the Earth, if the Earth is rotating, it's rotating at 1,054 miles per second at the equator, which means it's rotating slower in Illinois where he did the experiment. Let's say it's rotating 700 miles per hour instead of the 1054 down at the equator. Okay. So he took that speed and the impedance of the light beam coincided with that 700 mile per hour speed. Okay.
Mhm.
So he found his ether. He found all the ether that he's looking for to an amount of 98.6%. So there's what, 1.5% margin of error.
Mhm. Mhm.
So this was puzzling to him. He goes, why didn't I find the same ether in my 1887 experiment when I was measuring with the Earth supposedly going around the sun?
Mhm.
But now that I'm measuring rotation, I get the full ether effect. Okay, how is that possible? Well, he didn't have an answer. He didn't have an answer. And now, there's a lot to this, but I'm just going to shorten it up for you.
Mhm.
Um, here's the best answer for you.
Mhm.
The best answer is that the Earth is not rotating, but the universe is rotating around the Earth. Okay, why? Well, because it's moving at a certain speed, and if the Earth is stable and it's not moving, then that ether is going to impede the light beam going in that direction. Okay,
Mhm.
so that was the best, but who's going to accept that kind of answer? Nobody.
Only Christian and the religious people.
Yeah, exactly. Because again, if that's the case, then it means the Earth is in the center of the universe, and we can't have that. You see,
Yeah.
because all of our science will be overturned. That means we've been wrong for 500 years about one of the most simplest concepts known to man. What goes around what? And if we got that wrong, what else did we get wrong? You see? So it affects everything. So they're not about to admit that. But here's the problem for that. If you're going to be a Copernican, you need a revolution around the sun in 365 days, and you need a daily rotation of the Earth. The experimental evidence, that's the two Michelson experiments, only gave them one. The Michelson-Gale experiment showed there was a rotation. It didn't tell them what was rotating against what, it just showed them the daily sidereal rotation. But the Michelson-Morley experiment in 1887 didn't give them a revolution of the Earth around the sun. But if you're going to be a Copernican, you have to have both of those. Otherwise, your theory is falsified. But the geocentrist comes along and says, hey, look, we only need one. We only need to show a daily rotation. And that's what the Michelson-Gale experiment shows. Except it's not the Earth rotating, it's the universe rotating around the Earth. So we've solved the problem, you see. So now that experiment, it's hardly ever talked about in the literature.
Yeah, I never heard of it. So it's a Michelson-Gale experiment. They use interferometer technique, right?
Yes, they just changed the orientation.
Yeah, so that technique shows the speed of light is changing depending on the direction.
Yes.
So that single experiment shows two things. Speed of light is changing, plus there is a drag, ether drag, right?
Yeah.
10 miles per second or something like that.
Yeah, they would be the same thing. The ether drag is causing the light speed to change.
Exactly.
Yeah.
So your one interesting point is the clock ticking. So clock ticking, some clocks tick slower, doesn't mean that there's no underlying universal reference frame. But the relativity theory is saying because in one location clock can tick slower or faster, so and every reference point is valid, so time travel is also possible, future travel, going to the past, or everything is possible. So that generates multiple paradoxes like grandfather paradox and the twin paradox. In either way, because the grandfather paradox violates causality, and also the twin paradox creates confusion of the fact. For example, in twin paradox, traveling in the future, one person might die and another one is alive. But in other contexts, for example, if I say that Earth is actually moving away from the rocket is stationary, in that regard, the rocket guy will be dead. So if I combine these together, you cannot find the truth. One is saying the Earth person is dead. The other saying rocket person is dead. Actually, who is dead? See, there's no so it's a different result. In one universe, they will invoke multiverse in that situation. That in one universe, he's alive. In the parallel universe, the other guy is alive. So both are true.
It's just like Schrodinger's cat, remember?
Exactly.
Well, you look in the box, 50% of the time he'll be a dead, 50% of the time he'll be alive.
Yeah, it's very counterintuitive, and actually it makes intellectual pursuit frustrated because the moment you see actually there's no point of seeking for truth, people will get frustrated and they'll stop investigating.
Yeah.
But if you can stimulate them, no, there is an underlying truth, and it's findable. Like if you study hard, you can find it. But our scientific world actually says there's no underlying truth, everything is relative, and the moment you say something, they will find another excuse to debunk it by quantum relativistic effect.
Yeah,
everything is like magic word.
Yeah.
They can explain
it's like a wax nose that they can bend any way they want, you see.
Interesting. Yeah. Most important question that I had in my mind, to preserve the causality, to preserve the sanctity of time and universal universal reference, so that something or somebody, if they want to check what's going on, they can check because they're the reference. But with the relativity, everything is relative, so nobody has a valid point of like.
Well, that's what happens when you keep light speed constant, whether it's here or out in space. You see, in a rotating sphere, however, light speed is going to be faster the farther you are away from the Earth, because light speed will go faster because of the centrifugal and the Coriolis forces.
Mhm.
You see, so light speed at the rim of the universe is going to be so much faster than it is on Earth, 186,000 miles per second on Earth. Who knows what it's going to, I mean, you could calculate it out, okay, but it's going to be a lot faster out there than it is here.
Okay. Yeah, that nobody mentions anywhere actually.
No. And so they're going to have all this confusion about time and distance and all this because they have no way to communicate with the outside world in our time, you know. And so this all started when Einstein started fudging with time and dilated the time just to answer Michelson's experiment.
Yeah.
That fact led to it led to the multiverse, basically.
It's like a single crux against which everything is diverging. That's the final like hub. Exactly. And the speed of light was my greatest concern, because now what they have already done, they have changed the definition of meter. And like in old time, the meter was defined by a rod, physical object from here to there. But now they change the definition of meter by the speed of the light in a particular fraction of second, so that nobody can disprove the speed of light is changing because it's circular. The reason
this is exactly what they did in the Michelson-Morley experiment. When you change the length, you're changing the meter to accommodate the speed of light.
Exactly. Now they officially have done it. Now the international standard definition of meter is the amount of space that is traveled by light in a particular time.
Yeah. Now here's an interesting point for you. When in the Big Bang Theory, they had a big problem with this, because if light can only go 186,000 miles per second, well, that must be the same for gravity and every other force. So how are you going to have this big explosion if it can only expand 186,000 miles per second? And you know it's going much faster than that. And how is one part of the expanding universe going to communicate with the other part that's a lot more than 186,000 miles apart? How's that going to happen? Okay, so this became a big problem. It's called the horizon problem. And they had no way to fix it until one day, this man from MIT, his name is Alan Guth, thought up, oh, I'll tell you what we do. We just have this hyperinflation of the Big Bang, where we take away the time element, so to speak, and take away the obstacle of the speed of light, and just have it expand 10 to the 35 meters in 10 to the minus 35 seconds. Boom! You know, that's how it happened. So fast that you couldn't even see it, you see? And that's how they solved their inflation problem. And what was the cause of that? It was the limited speed of light.
Yeah. I heard another one expansion similar to those from the scientists. They're saying that nothing can move faster than light, but the space itself is not a thing. So it can move and expand faster than light. So no problem.
Yeah. Well, see, that's what it did when they got to the other side of the universe, when they had to expand it faster because they had to save Einstein's theory. Okay, that's what this is all about. They had to save Einstein's G equals 8 pi tau. That's what it is. They had to save that theory, and so they had to expand the universe faster than the speed of light. Okay, now you know what they did? They switched from special relativity to general relativity, because general relativity says that things can go faster than the speed of light, and that's what they use today for this super expansion of the universe.
There are a lot of peculiar finding. Actually, it doesn't make any sense. For example, another one that is related to little like in geocentric view, For example, the redshift, the more remote the area, the redshift is roughly equivalent. For example, in this direction, the highest amount of redshift that we can see has a particular value. But this side has less value, then it will mean that we are not in the center. But actually, if you look the farthest object from this direction, the amount of redshift in this direction, that direction, everywhere is the same. That means Earth appears to be center depending on the redshift in all directions.
Yeah,
For example, exactly, right?
that's what Hubble found in
Exactly.
1929.
But how can they explain this one with the other theory that Earth is not in the center? You cannot explain. It has
Yeah.
Earth has to be in the center.
Yeah. You see, and this is why I cover Hubble in the book, because he's the pivot point for all this redshift stuff. He saw the redshift from everywhere in the universe coming to him with the same amount of redshift wherever he looked. And if he saw a blue shift in one direction and a redshift in the other, that would show we're not in the center.
Exactly.
But he sees redshift everywhere. Okay. So he says, this puts us in the center, and I hate this. We can't have this. You should hear him in his book. I mean, there's like a dozen times where he's like out of his mind. We can't have this. So how are we going to explain it? And here's what he comes up with. He says, all right, here's what we do. We take away the center, and we'll just have a surface for the universe. And it's like a balloon. And we'll put all the galaxies on the surface of this balloon, and then we'll blow up the balloon so it expands. And what's going to happen? Every galaxy is going to see the same redshift from every other galaxy because they're all expanding on the surface. That's how you explain it. You see, what was the cause of it?
Theory, depending on what they want to explain. One is multiverse, one is hyperdimension. That universe has more than 3 dimensions. For example, Einstein introduced 4th dimension as time, not independent, because traditionally people thought time is actually independent of space. They just mingle together, but still has independent existence.
Yeah.
But Einstein says no, time doesn't have independent existence. So they added 1 dimension. Now the string theory is adding 10 more dimensions, 26 dimension, etc., etc.
Yeah.
Now, in order to reconcile the quantum physical cats like Schrodinger's cat paradox, they're introducing multiverse. Now, in order to eliminate the complexity problem, they're introducing again multiverse. That in multiverse, our world is naturally fine-tuned to have the natural laws. Because that question you cannot explain unless you introduce multiverse. That there are infinite number of multiverses. By accident, we have natural laws. So that things are running on. So it's always like they're adding theories just to keep their intention, that the original intention.
Yeah, that's what's happening.
That there's no role of really like religious understanding of the world, because the entire worldview is formulated against the original religious worldview. Most of the groundbreaking big thesis or hypothesis actually comes from a religious person, like for example, even Big Bang theory came from a priest, right?
Maitre, yeah.
Exactly. Then genetics, Gregory Mendel. Exactly. Then in probability theory, Thomas Bayes, like Bayesian statistics.
Yeah.
So then so many religious people contribute towards the science, but their contribution always gets recognized after their lifetime.
Yeah.
So maybe your contribution, if even though you don't see during your lifetime, people will appreciate that, like Galileo, scientific community appreciate his work.
Yeah.
But maybe down the road, 100 years from now, people will appreciate your work because you made a movie. Because Galileo did not make a movie.
Yeah,
he did not defend his position by making a movie. But you showed the literature, you interview a lot of different people, and you propose your thesis with experimental data.
Yeah.
That I don't think even Einstein did not make a movie out of his theory. He couldn't, because he didn't have the good data, right, to show.
Yeah.
But at least you made a movie. That movie will stay as long as our human community persists without a disaster.
Yeah. True. Thank you for that.
Thank you so much for your work. Although as just for understanding, I'm a very curious person. I can pursue any direction, and lot of things I'm not still decided, but at least I'm open to listen.
Yeah. Yeah.
That's why I'm personally very interested to talk about. For example, your work has multiple dimensions. One is Copernican principle and geocentrism. As a package, you also defended against this flat earth community. I understand
Yeah.
you did extensive work on that.
Yeah.
And actually, I think flat earth is a psyop by CIA just to debunk
Yeah.
just to debunk this geocentrism. Because one thing is common in both theory: the earth is not moving.
Yeah.
People don't see it.
Yeah. Right. We thought the same thing.
Exactly. They're more focused on flatness, and they're more focused on the moon is doesn't exist. It's just a light, or etc.
Mhm.
But one thing is common: the earth is not moving.
Yeah.
Exactly. They tend to overlook that. So from an outsider, when somebody talks about relativity, actually it's not about relativity itself. The package goes back to geocentrism. That's
It
why somehow it is not being discussed, but we need to start talking about it. And that's why thank you for your work and making the movie so that people can understand and appreciate the complexity.
Okay. Great. Well, thank you so much for that. And thank you for having me on your program.
Thank you so much. We'll meet again.
All right. Take care.